everyone. I'm Sheng Kai, rising third-year ME graduate student from Stanford University. I will take my PhD qualification exam in 3 weeks, and thermodynamics will be one of my exam topics. So I feel this is a good time to summarize what I have learned about thermodynamics and to practice talking about it in a comfortable way. Also, this is a perfect time to share my understandings about the topics and also my experience in exam preparation. So I hope this video will be useful to those who want to know more about thermal, and if you are a PhD student taking qualification exams like me, this can bring you some inspirations. So that's a little bit about myself. Let's talk a little bit about this video. So this is gonna be a high-level overview of graduate level thermodynamics. So if you have not taken any undergraduate thermal classes, or if you have never heard about thermodynamics, you might feel comfortable to start with reading undergraduate thermal. So the bottom line is, before you start watching this video, I hope you do know some fundamental concepts like first law, second law, state equations, or phase diagram, because we'll be talking about them a lot, and throughout the video, I'll just assume you know the basics. So, since there are a lot of materials to cover, I will break them into 3 parts with 8 sections in total. So, we will start with a single component system. We'll be talking about production accounting, conservation equations, and then entropy and exergy, which is related to the entropy. And then we will do psychoanalysis and talk a little bit more about state equations. Then we will move on to the multi-component systems, starting with the simple case, which is a homogeneous phase system. Then we will look at general multi-physics system, and but we will not consider chemical reactions, and we will leave this complexity to the third part. And then I would like to spend more time on a special topic, the binary mixtures, because it's simple and interesting, and it's very important for us to know well before we start to learn about the more complicated multi-component system in the real world. And then finally, we'll talk about reactive systems.